is that you get a really high voltage and it actually jumps across the air. And that's why you can see it kind of orange and purple, because it's exciting the air molecules and they let off light. And then it heats up the air because it's high resistance. And hot air rises, so it starts pulling it up. And then as it gets further and further apart, it's too difficult to stay in the arc, so it breaks and then it starts over again. Sometimes it gets stuck. So you guys can kind of hear that, right? It's kind of
so here we got about 8,000 volts coming out of it. Jacob's wire was 12,000. It's a little less, but we're able to manipulate the. Here, I'm shooting it against a flat surface, which doesn't sound as loud as the 2 points over there. It's still here for me. Yeah, so you can play any music, it doesn't matter, from your iPhone or whatever. Pretty cool.
Those are LEDs, and so there are companies called, like, one of the major manufacturers of that is Louis LEDs. They're based in San Jose, and they design all the semiconductor and the stoplight electronic design also.
Do you have classes where you're trying to design things to be more sustainable, to last longer, to, you know what I mean? Are you have any kind of focus in that now about sustainability in your design and manufacturing and that kind of stuff?
Well, certainly, I think you need to find David Braun. David Braun is upstairs right there, and much of what he does focuses on landfill, so certainly they take a course from me, and that is EE 111, the first course that all the freshmen take. And so, what do I tell the freshmen? So first, I tell the freshmen, you know, what is it that you're entering in this major? But the second thing I tell short-term plan together, you need to get your long-term plan together. And sometimes people may have that kind of in their head, you know, kind of what they're going to do a little bit. But you have to
actually spit out something that looks just like a battery. So that's how like a laptop charger works, right? Plug it into the wall, it goes in this little box. This box kind of looks like this, and then you plug that into your laptop and it charges it. Same thing with cell phones and pretty much everything else. So we got lots of other little things in here. Transformers.
Wah, wah, wah.
Has anyone shocked himself yet?
Yeah, so I think they said, what the heck were you guys doing?
We didn't do it.
Double D did it? And I don't know, somebody...
He's like, what this right here?
Project experiment. So what I'm doing here is I'm reading power coming from that turbine, which is powering that sign, and I'm sending that data wirelessly to this guy over here.
Oh, it's gonna be like dizzy.
So I'm sending the power readings to that computer over here, and I'm also sending the wind speed readings to that laptop over there, which is coordinate on that Excel file. And that's what we have. So basically what that is similar to that wind turbine we showed you guys. That's
Really fun. Have kids.
you guys will be powering the house right now.
Really?
Yeah, so this is 1.2 kilowatts. So maybe if you get 5 of these, you can
probably on the order of maybe 100 or 80. And then we pass it through the turbine. A lot of the wind goes to each side, you miss it. And so we're only able to recapture about 5 watts of that 1,000. So that's works out to 0.5% direct conversion. Yes.
And where does all the energy go?
Here, there's just a little battery right inside this. There's a little 12-volt battery in here, and that is just charged up.
No, the energy that you're losing when creating.
Well, some of the energy is just in the wind that blows out here. Okay. There's some losses. But so what we do in the real world when we generate with wind is we're using free wind energy to do this. right? So if we did that, then we'd be getting 5 watts out of no electrical input.
So it's just a simulation? It's
Yeah,
not-
so this is
okay.
just kind of a simulation, kind of looking. Something like this that we're looking to develop on a little bigger scale would be to, test different turbines and different.
And blah blah blah. Something about
You can filter this way, guys.
possible deck. Yes, that is the one. So this thing right here,
It's possible death.
I would say it's likely death.
Okay,
If you were to like stick your fingers in here, it would pretty much kill you. So this 120 volts, just like the wall, that'll kill you. 240 volts, that'll definitely kill you. But what we do here is we have industrial applications. You have a question?
Yeah, what do you use the danger ones for?
This thing?
Yeah, what do you use that much for?
That's the DC voltage, which is
It's already connected internally, so we don't want anyone connecting it and making it short.
Oh,
Through the back, it's already connected, so we don't use it.
yes.
What do the colors represent?
I think it's just kind of to visually tell you that this is all 240 volts, 3-phase, just like this guy.
Or kill you.
That would probably do something very bad. I don't know if these are in phase, so. But there's single phase, which is what you use in your house, and then there's also a 3-phase, which is what they use in industrial applications. So a bunch of like power plants and manufacturing plants. So for big motors, things like that, they use that stuff. Yes.
Is there a double phase?
Sort of.
Good question.
You actually use something that would be close to